Okay, problem number 6, world's longest learning guide ever. The conic section has vertices at -2, 1 and -2, -9. From that, a couple pieces we can already figure out. Notice that it has vertices, not just a single vertex. This should tell you that we're dealing with either an ellipse or a hyperbola, but not a parabola because we have two vertices, which means we need an x squared and a y squared term. And so, what do we know? Well, notice that the x value here is the same for the vertices, which means they are in line like that, which means this conic section is oriented up and down. Now let's look at the foci to determine if it is a hyperbola or an ellipse. Well, again, notice the x values are the same, and let's go ahead and plot these. Let's go ahead and actually plot this real quick so we can do this. X value is going to be -2 for all this stuff, and notice we have pretty negative y values, so I'm going to draw my axes like that. I'm going to say 1, 2 right there. And let's go 1, 2, 3, 4, 5, 6, 7, 8, 9 right there. So -2 and +1 is going to put me right there. -2 and -9 is going to put me right there. There are my vertices. And where are my foci in relation to that? Oh, well, they're at -2, -1, and -2, -7. So notice that my foci are on the inside of my vertices, which tells you what type of shape this is. It tells you that it's going to be an ellipse. Can you picture it? The foci are in between the vertices, which means it is an ellipse. Boop, 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 just like that. Alright, well, what else do we know? What can we figure out from this? Well, we can determine where the center is. It's going to be perfectly between the vertices and perfectly between the foci. So let's see, we go 1, 2, 3, 4, 5, 6 between each focus, which means I can go up 1, 2, 3 from that bottom one to get to the middle. And what does that tell me? Well, that tells me that my center has, first of all, has to be the same x coordinate, -2, but it tells me that that y value is 1, 2, 3, 4, -4 right there. And again, where else did -4 come from? Well, think of it as -7 minus -1, which is, well, -6. But let's think of it as a distance divided by 2, gave us our 3, halfway between each, and we found -2, -4. You can also think of it as 3 down from the top point, which has a y value of -1. Either way, you get to -4. So we have our center, which can tell us now a couple things. We know that the distance from the center to the vertex is a. So that distance right there is a. And what is that distance? Well, that's 1, 2, 3, 4, 5. So we know that a equals 5. What else do we know? Well, we know that the distance from the center to the focus is c, and that is 1, 2, 3. We already determined that a moment ago. So we know that c equals 3. And so we need to use our equation for the ellipse. A squared equals c squared. How do I write this? C squared plus b squared. Again, there you go. You have the big thing plus the two small things added together. Remember that a is always greater than b, and a is also always greater than c, since that c value, those foci, are in between the vertices. So we have this relation right here. So we have 5 squared equals 3 squared plus b squared, which is what? Well, it has to be 4, because this is a 3, 4, 5 triangle. You could get there the long way, but that tells me that b is 4, which tells me actually that I'm going to be drawing into my work right there, because my b value is the distance in the other direction, the conjugate axis. So let's go 1, 2, 3, 4 there as well. There's going to be 1 point right there. Here's going to be my second point right there. And now I can draw in this ellipse. And kind of hard to do it super accurately for drawing like this, but we do the best we can. And from the way I've drawn it, it kind of looks like it's a horizontal ellipse, but that's just because of my poopy scale. That really is vertical. We know that the distance between the vertices is 10, and that's your up and down distance, and we know the distance between the co-vertices is 8, and that's your side-to-side difference. So it's going to be pretty close, but we know it should look like that. Everything's at least plotted in the correct spot. So now we know our A, B, and C, we can write the equation of this ellipse. Well, again, what's the orientation? It is vertical because A is running up and down. Notice your foci are in line up and down as well. So a vertical ellipse just means that the larger denominator is underneath the y term. But also think of it like this. From this point, what did we do to get to this vertex? Well, we went up by 5. So that tells me that underneath my y term, I'm going to have a 5 squared. And what do I need to add or subtract to that y before I square it? Well, that needs to be the y value of my center. My center has a y value of -4, so it's going to be y minus -4 is y plus 4. That squared over 5 squared because I went up 5 from the center. Well, how far to the side there did I go? Well, I went 4 out to get to my covertice, which tells me that underneath my x term, side to side, I must have a 4 squared, and that is an x minus the x value, which is -2, so x plus 2, quantity squared. All of that equals 1. So that is my equation written in rectangular form, and now we need to write this equation in parametric form. And for that, we need to think about the Pythagorean identity. We know that cosine of theta squared plus sine of theta squared equals 1. And you should recognize how similar these two equations are, which allows us to make the substitution cosine of theta, that thing squared, equals x plus 2 over 4. That thing squared in our conic section. And we can solve this for x. The 4 needs to be multiplied up, so we have a 4 cosine of theta, and then I would need to subtract 2. So 4 cosine theta minus 2 equals x. And what about y? Well, we're going to make a similar substitution and recognize that my y plus 4 over 5, all of that squared, is pretty similar to that sine squared. And so we're going to make the algebraic substitution sine of theta equals y plus 4 over 5. And notice I got rid of all of those squares because I could just square root everything. And so let's solve this for y. What do we need to do? Well, we need to multiply that 5 up. So we're going to get 5 times the sine of theta. And then what? Well, then I need to subtract that 4. Minus 4, that equals y. And now I have my parametric equations right there. X equals 4 cosine theta minus 2, and y equals 5 sine theta minus 4. But notice really what happened here. Really, I ended up with x equals b cosine of theta plus h, and y equals a sine theta plus k, which is kind of cool and actually easier than a and b. I just think of whichever one is underneath the y, that one goes with the y. Whichever one is underneath the x, that one stays with the x. And so we have our rectangular form, our parametric form, and a pretty old graph.